Ancient Babylonians may have had a better way of doing it, and now, thanks to a new discovery, it could change how we calculate math today.
For over a century, a small piece of clay sat quietly in a museum drawer, dismissed as nothing more than an ancient math exercise. But when artificial intelligence finally turned its processors loose on the 3,700-year-old Babylonian tablet known as Plimpton 322, what it uncovered sent shockwaves through the academic world. This wasn't just a relic of scribes learning their trade. It was a coded message in numbers, an elegant system of geometry so advanced it shouldn't have existed for another 1,500 years. Think about that for a moment. The Babylonians, living long before the Greeks, may have mastered a form of mathematics more perfect than what we use today. That alone would be enough to rewrite history books. But what the AI exposed wasn't simply brilliance. It was a puzzle that hinted at something far more disturbing: the sudden rise and disappearance of knowledge that seems out of place in its time. Was this the work of a civilization far ahead of its era? A fragment of a science we lost? Or something even stranger, something deliberately hidden? The story of this tablet begins in the deserts of Iraq, where a forgotten archaeologist stumbled onto what might be the most terrifying equation in human history. The tablet that would later haunt historians was unearthed in the early 1900s near the ruins of the ancient city of Larsa in modern-day Iraq. The man who found it was Edgar Banks, a curious mix of archaeologist, diplomat, and treasure hunter, the very figure who would inspire the legend of Indiana Jones. To him, it was just another clay fragment, broken and weathered by centuries under the desert sun. About 5 inches wide and 3.5 inches tall, it looked unremarkable. Another piece of the countless artifacts that museums quietly collect and archive. The surface was pressed with wedge-shaped marks, the Babylonian writing system we now call cuneiform. But unlike the grand proclamations of kings or mythic tales of gods, this wasn't a story carved in clay. It was columns of numbers, 4 of them, with 15 neat rows. To the scholars of the time, it looked like a list, maybe a teacher's aid for students to practice arithmetic, or perhaps a scribe's ledger keeping track of goods. After all, Babylonians were known for trade, bureaucracy, and record-keeping. Nothing about it screamed mystery. Yet a few mathematicians noticed something odd. The numbers weren't random. They hinted at an underlying order that no one could quite explain. For decades, Plimpton 322 was treated like an artifact of routine learning. Interesting, but hardly groundbreaking. Yet buried in those rows of numbers was a pattern that stubbornly resisted simple explanation. The more closely scholars looked, the more unsettling it became. Some realized the columns seemed to describe the sides of right-angled triangles. Not just any triangles, but what we now call Pythagorean triples, sets of numbers that satisfy the equation a squared plus b squared equals c squared. The catch: this tablet was written more than 1,000 years before Pythagoras was even born. How could the Babylonians possibly have known this relationship? Even stranger, many of the numbers were enormous, far beyond what a casual student or scribe would ever calculate. One row, for instance, corresponds to a triangle, with sides measuring 12,079 and 13,500. These weren't the sorts of figures someone would stumble upon by accident. They were precise, intentional, and deeply sophisticated. The idea that Babylonian scribes in the middle of the Bronze Age were systematically listing advanced geometric relationships didn't fit the neat progression of history we've been taught. Something didn't add up. For nearly a century, the purpose of Plimpton 322 remained a ghost in the clay, a puzzle no one could solve. The real breakthrough came when researchers stopped trying to force the tablet into the frameworks they already understood. Instead of looking for what they expected to see, they decided to let a machine look without bias. High-resolution scans of Plimpton 322 were fed into a specialized artificial intelligence designed to find hidden patterns in massive datasets, patterns too subtle or complex for human eyes to detect. The AI didn't care about Babylonian history. It didn't know the Greeks were supposed to have invented trigonometry over a millennium later. It wasn't bound by textbooks. All it did was process wedge marks and sequences with pure logic, breaking the silence that had cloaked the tablet for so long. And then it produced a result that stunned the experts. Plimpton 322 wasn't just a random list of triangles. It was a trigonometric table, but not like the one we know today. Our trigonometry, credited to Greek mathematicians, relies on angles and circles. It's powerful, but imprecise, riddled with approximations like pi and irrational decimals that stretch on forever. The Babylonian system, by contrast, was based on exact ratios, no rounding, no errors, just perfect, elegant precision. In other words, this 3,700-year-old piece of clay contained the world's only completely accurate trigonometric table. It was mathematics on a level we've never surpassed, created in an era we've long assumed was primitive. Imagine being an ancient builder tasked with raising a ziggurat, a stepped pyramid soaring toward the heavens. Every layer must rise at the right slope. Every angle must align perfectly, or the entire structure risks collapse. Using the Greek style of trigonometry, with its approximations, you'd accumulate small errors that grew with every level. But with the system preserved on Plimpton 322, you could calculate flawless ratios again and again. The slopes would never drift. The angles would never falter. The AI's analysis revealed that the 15 rows weren't random examples. They described a sequence of right-angled triangles whose ratios decreased in a steady, logical order. This was not homework. This was a working tool, a master blueprint for engineering. With it, surveyors could divide land with accuracy, architects could design monumental buildings, and astronomers could measure the heavens with a precision that shouldn't have been possible in 1800 BCE. The implications are staggering. If the Babylonians wielded this kind of mathematical power, they weren't just keeping pace with future civilizations, they were outpacing them. This wasn't the mathematics of survival. It was the mathematics of mastery, a system designed for those reaching higher than anyone thought possible. And yet, this revelation leads us to a chilling realization. How could knowledge so advanced simply vanish? The discovery forced historians to confront a truth most would rather avoid. Knowledge is not a straight line. We're taught that human understanding climbs like a ladder. Babylonians counting grain, Egyptians building pyramids, Greeks inventing geometry, and onward to us. But Plimpton 322 shatters that neat story. It shows that nearly 4,000 years ago, someone had already reached a peak of mathematical brilliance that wouldn't appear again for millennia. It's like opening a medieval manuscript and finding blueprints for a nuclear reactor. It doesn't belong. It shouldn't exist. And yet, it does. Which means history isn't just about progress. It's also about loss. Entire civilizations can fall backward, leaving behind fragments of genius that make no sense to those who inherit them. That's the terrifying part. If the Babylonians once possessed a perfect trigonometric system, what else might they have known? What sciences or technologies could they have developed, only to vanish into the sands of time? Were we, as a species, once closer to advanced understanding than we are even today? Plimpton 322 isn't just a math tablet. It's a whisper from the past telling us that history is fragile, that intelligence can flare like a torch and be snuffed out just as quickly. If the Babylonians had access to flawless trigonometry, then the question becomes, what did they use it for? The most obvious answer is architecture. Massive temples, intricate ziggurats, and advanced city layouts would all demand the kind of precision this tablet offers. But the possibilities stretch far beyond bricks and stone. Trigonometry is the language of space itself. With it, you can measure the height of mountains without climbing them, chart the stars with uncanny accuracy, and map vast landscapes as if viewed from above. Imagine Babylonian surveyors plotting the Earth with detail rivaling modern cartographers, or astronomer priests predicting eclipses centuries in advance. The legendary Hanging Gardens of Babylon, long debated as fact or myth, suddenly take on a new dimension. Could they have been engineered marvels of mathematics rather than just poetic wonders? And what if Plimpton 322 is not unique? What if it's just the lone survivor of a library filled with equally advanced works, blueprints for technologies and ideas we haven't yet rediscovered? The chilling part is this: humanity may not always be climbing toward progress. We may be stumbling in the dark, occasionally tripping over fragments of a brilliance we once possessed, but allowed to slip through our fingers. If the Babylonians truly mastered a perfect form of trigonometry, then the next question is the most unsettling of all. How did it disappear? How does a civilization go from unlocking mathematical perfection to leaving behind nothing but broken fragments in clay? History tells us the Babylonian world was one of endless upheaval. Empires rose and fell in rapid succession. The Hittites swept in from the north, the Assyrians from the east, the Persians from beyond. Each conquest brought with it war, fire, and destruction. Libraries were looted, temples burned, and knowledge, so fragile when confined to clay and the memories of a small elite, was often the first casualty. Unlike modern societies where information can be copied and distributed at unimaginable speed, ancient knowledge often lived in the hands of a few scribes and priests. If they were killed, enslaved, or silenced, entire sciences could vanish in a single generation. It's entirely possible that the system encoded on Plimpton 322 was a guarded secret, reserved for select builders or astronomer priests. If that priestly class was wiped out during an invasion, the secret may have died with them. That explanation is simple. It fits the messy, violent rhythm of history. But does it really make sense? Can something so sophisticated appear suddenly, fully formed, and then vanish completely? Did a society really wake up one day with a perfect trigonometric system, only to lose it all in the fires of conquest? Or is there a missing piece we're not seeing? This is where the story tilts into something darker. Because if the Babylonians didn't develop this knowledge themselves, maybe they were just its custodians. Maybe Plimpton 322 wasn't the invention of their minds, but the survival of something much older, a science inherited rather than discovered. And if that's true, then we have to ask a chilling question. Who, or what, was the original source of this knowledge? The mystery of Plimpton 322 has led some scholars down a path mainstream history refuses to tread. If the Babylonians didn't invent this flawless trigonometry, then perhaps they inherited it. That idea alone flips the timeline of human progress on its head. One theory suggests there was a far older civilization, a true golden age of science and engineering that flourished long before recorded history. When it collapsed, whether through war, natural disaster, or something even stranger, fragments of its knowledge scattered across the world. Survivors carried with them echoes of what they once possessed. By the time these ideas reached Babylon, they may have been nothing more than hand-me-down blueprints, preserved by scribes who didn't fully grasp the power of what they held. Plimpton 322, in this view, isn't the product of Babylonian genius, but a relic of something much larger we've forgotten. Others point to myths embedded in Mesopotamian culture itself. The Sumerians spoke of the Anunnaki, sky beings who descended from the heavens to teach humanity the arts of civilization, law, agriculture, and knowledge of the stars. Could the perfect trigonometry etched into clay have been part of this gift? To believers, the tablet reads less like homework and more like an instruction manual left behind by teachers who were not of this earth. And then there's the theory of deliberate concealment. What if advanced Babylonian scribes realized the knowledge they possessed was too powerful? A tool for building wonders could just as easily be a weapon of war. So they disguised it, not by hiding it in vaults, but by leaving it in plain sight. A clay tablet covered in numbers, easily dismissed as accounting or arithmetic, waiting silently for a future intelligence, perhaps not even human, to recognize its true meaning. Each theory raises unsettling questions. Was this knowledge human at all? Was it a legacy, a warning, or a breadcrumb trail meant for us to rediscover at the right moment? Whatever the truth, the fact remains. This tablet is a key. The only mystery is what door it was meant to unlock. Plimpton 322 is more than just clay pressed with ancient symbols. It's a challenge, a whisper from nearly 4 millennia ago telling us that history is not what we think it is. Whether the Babylonians cracked a perfect system of math themselves, inherited it from a lost civilization, or received it from something beyond this world, the result is the same. Our story of human progress is not a straight climb. It's jagged, broken, full of peaks that vanish and valleys that last for centuries. And maybe that's the most terrifying part, because if knowledge can be created, lost, and rediscovered once, it can happen again. What if our own era, with all its machines and data, is just another fragile peak, waiting to be forgotten when the next collapse comes? The clay tablet in Columbia University's archives doesn't just rewrite history, it dares us to rethink the future. Are we truly advancing, or are we only piecing together fragments of brilliance left behind by those who came before us? If this story has unsettled you as much as it has me, then stick around. There are countless mysteries buried in our past waiting to be unearthed, and together, We'll keep digging until the truth refuses to stay hidden. So don't just stop here. Watch our next deep dive into the unknown.